All right, and finally, the last homework problem of the Calculus 1 course here is going to be the utilization of L'Hopital's rule. Actually, it tells me what form it is. I could figure out what form this is. I don't need to be told what form this is. Substitute a -1 into this, and we get -1 to the fourth is going to be +1. -1 cubed is a -1. -1 times this is -2 plus 2. And then -1 plus 1 is 0. So these cancel out these. This becomes 0 over 0. So 0 over 0, we call this an indeterminate form. And for indeterminate forms, we use L'Hopital's rule. That's what we want to use. So L'Hopital's rule basically says when you get an indeterminate form like this, we're going to take the derivative of the top and the bottom. So we will say the derivative of the top is going to be 4x cubed plus 3x squared plus 2. Derivative of the bottom, the x just becomes a 1. So now we ask, can we take the limit as x goes to -1 of this? The answer is it looks like probably we can. -1 cubed is -1 times 4 is -4. -1 squared is 1 times 3 is 3 plus 2. And we're going to take that over, well, getting good with my eraser here now. Pointer options pen. We're going to take that all over a 1. And we say that the limit then is equal to -4 plus 3 is a -1 plus 2 is a 1. Let's make sure that's a positive 1. Yeah, 5 minus 4 is positive 1 over 1. Oh, imagine that. It's equal to 1. That's the limit. Now what's interesting is, again, I've told you this on other problems, don't be afraid to graph this. So let's keep the annotations there. Let's go into Desmos real quick, and let's graph this guy, which the original function was x to the fourth. Oh, yeah, that's fine. X to the fourth plus x cubed plus 2x plus 2 divided by x plus 1. And that was our original function. Let's zoom out a little bit. I don't seem to see the function. There we go. And as we go to -1, so the limit again was what happens, what does the function go to? What does all of this go to as we approach -1 on x? So we'll jump out of there for a second. Keep that. As we approach -1 on x, so I'll zoom in a little bit here. As we approach -1 on x, so here's x equals, oops, I guess I can't write on that. X equals -1 is right there. So as I approach -1 in this direction, I'm going towards 1. As I approach -1 in this direction, I'm going towards 1. So the answer to your question is the limit of the function as x approaches -1 is 1.